people kind of get a kick back away from it.
Yeah.
As you know, the introductions in this lab don't last very long, so pay attention. It's going to give us 12 seconds. No, it's my pleasure to introduce Jimmy O'Donnell for his exit seminar for his dissertation. I would like to also, he will do it also, but to thank the members of this committee. John is here, John Thompson is here, and then Pete is on jury duty, so he would probably show up. He was kept there, so unfortunately he can't be here. It's been a real pleasure to have Jimmy in the lab. He's been incredible. I learned a lot from him. I will make fun of him maybe later during the roast, no worries. But for serious things, in the lab he's been really great. In conversations, amazing. I really learned a lot. I think that he is probably one of the person I know that has gone over his personal boundaries so many times, doing stuff that he had never tried before and excelled at it. I was very impressed. And then in the field, it was really fun to have him. We have taught together with Pete several classes. That was great. And then 2 times I also was able to be in the field, just the 2 of us. And this was in the Philippines and Madagascar. And that was a blessing and a curse. The blessing was that he knows everything, really. So we know about the same about fish, so that was great. We could talk about it. And then I could sit back and relax, and he would teach me everything about birds, inverts, terrestrials and marine, herps, everything. So that was really great. The curse, of course, is that our ADDs were feeding on each other, and staying focused was extremely difficult. We would talk about everything except what we were supposed to do. But as a biologist, I learned a lot from him, and so it was amazing to have him in the lab. It was really fun. So I'm really happy to see him go to Seattle, but I'm going to miss him a lot also. That was a great few years with him. So without further ado, this was the longest introduction I've ever done in my life.
Thanks, Giacomo. It's kind of customary now to do your acknowledgement slides first. So I wanted to take a second to thank the 2 most important sources of support during my PhD, my mom and my wife, Sally. They've really supported me a lot leading up to grad school and then been in it through the long haul through it. So thanks a lot for all your support. These gals know that I think clownfish are pretty all right, but this is what really keeps me up at night and gets me out of bed in the morning, is thinking about all these different kinds of organisms. The incredible diversity of life on Earth is just a little bit worrisome sometimes. It's too much. But if you try to simplify things and make some sense out of it and see sort of what the origin and how things are maintained, I think I come away from that thinking that there's 2 really important forces, at least in my mind. And the first is that through reproduction, organisms share genetic material that gets passed down over generations. And so if you have these really simple organisms that are reproducing, you have families that share genetic material that make up populations, that make up species. These obviously aren't existing in a vacuum, so we have red species over here, and maybe that species is reproducing and interacting with the white species. And maybe it has a negative effect on the white species. The white species has a positive effect on the red species. And you can think of that as something like predation, parasitism. Other situations, you could have a positive interaction for both parties, like the pollination of a hummingbird pollinating this flower here. Or if you have two similar species or even kin that are competing for the same limited resources, you could have competition which negatively affects both participants, like these two coral heads fighting for space. And what I really get going about is that this feeds back into the reproduction part. So then these interactions affect how the genetic diversity of life is organized within species, across species. And I think that's really fantastic to think about. So in our giraffe example, the red species, the cheetah, produces more offspring. The gazelle produces no more offspring. In the hummingbird example, both parties continue producing more offspring. So hopefully you're on board that these species interactions shape biodiversity over short and long time scales as you accumulate over many generations. But also interactions vary at multiple levels, and I think that's really fun to think about. So take these two different raccoons, one dyed red, no just kidding, this is a red panda, and this is a raccoon in the same position. But the raccoon eats basically anything, red panda almost nothing but bamboo. That's pretty crazy that you can have two things doing such getting along in such different ways. Even our own John Thompson's work has showed that among populations you can have two species that are interacting in one area be mutualist, and in another area of their exact same species range be completely antagonistic. Work out of Jim Estes and Tim Tinker's lab has focused on sea otters and shown that even within a population, at the level of the individual, you have individual sea otters specializing on different prey items. So I wanted to find a system that would be tractable, and at the same time I could sort of look at this interplay between species interactions and that organization of biological diversity with an eye towards specialization, and to that end I chose to work on the clownfishes, or anemone fishes. These are about 30 species in the family Pomacentridae, also known as the damselfishes. They're in two genera. One species is in Premnus and everybody else is in Amphiprion. They're obligate mutualists of sea anemones, so you never find a clownfish without an anemone, but in some cases